In this video, we're going to take a look at division by complex numbers. So here in the denominator, we have a complex number, 2 minus I. And remember that I is the square root of -1, and we can't have radicals or square roots in the denominator, so we'll have to go through the process of rationalizing the denominator. So we're going to multiply the numerator and the denominator by the conjugate of this denominator, which in this case will end up being the complex conjugate. So instead of having 2 minus I, we're going to multiply the top and bottom by 2 plus I. Okay, so I'm going to go ahead and put all these in parentheses since there's two terms here. In the numerator, we'll distribute, and we'll end up with 10 plus 5i. In the denominator, by multiplying by complex conjugates, we only have to worry about the firsts and the lasts because all the other multiplications will end up canceling each other out anyway. And that's why we go about doing it that way. So 2 times 2 is 4. And then we have a negative I times a positive I makes a negative I squared. And I squared, of course, is -1. So we're subtracting this -1, so we really can say we're adding +1. So 4 plus 1 is 5. So I'll have 10 plus 5i all over 5, which now, because I have a complex number on top, I need to break this fraction up into two separate fractions so I can write the final answer in a plus bi form. So we'll see this 10 over 5 can be reduced, and then we have this 5 over 5 that can also be reduced. So when I do that, my final answer will be 2 plus I. And this will be the quotient whenever I take 5 and divide it by the complex number 2 minus I. In this second example, I'm going to take a look at -4i, and I'm going to divide that by the complex number 3 minus 5i. So this division by the complex number will get done actually by doing a multiplication by 1. So what that's going to look like is I want to multiply the numerator and the denominator by this complex conjugate. So I'll multiply by 3 plus 5i. And again, this is in an effort to get rid of the I in the denominator because the I represents the square root of -1, and we cannot have square roots or radicals in the denominator. We have to go through the process of rationalizing that. So I'll put all these in parentheses here. In the numerator, I know it's just going to be a matter of distribution. So -4i times 3 will be -12i, and then minus, it looks like 20i squared. In the denominator, we just have to multiply the firsts and the lasts, so 3 times 3 is 9, and minus 25i squared. So we can simplify a few things. This I squared here and the I squared here, they're both actually -1, which will turn this negative into a positive, and will turn this negative into a positive. All right, so I have -12i plus 20, that's in the numerator, and the denominator will be 34. But I have to write these in a plus bi form, so the real part has to come first, and the imaginary part second. Also, we have to separate this fraction into two separate fractions so I can write them in a plus bi form. So 20 over 34 minus 12i over 34, and of course both of those can simplify nicely. So we'll have 10 over 17 minus 6 over 17i. And again, to ensure it's in a plus bi form, this I needs to come along separate from this coefficient. So 10/17 minus 6/17 I is the quotient whenever I take -4i and divide it by this complex number 3 minus 5i. In this third example, I'm going to take the complex number 3 minus 4i and divide it by, actually its complex conjugate, 3 plus 4i. So in an effort now to do this division, remember the division actually happens to turn into multiplication by 1 because we're going to multiply the numerator and the denominator by the complex conjugate of this denominator. So 3 minus 4i and 3 minus 4i. So here's the multiplication by 1 because we're multiplying by a fraction whose numerator and denominator are the same things. So I'm going to put parentheses around all this stuff. Okay, and so the top is just going to be a series of distributions. And in the bottom, I just need to multiply the firsts and the lasts. So let's go ahead and get to work. 3 times 3 is 9. 3 times negative 4i is minus 12i. Negative 4i times 3 is another minus 12i. And negative 4i times negative 4i is plus 16i squared. And that's all over 3 times 3, which is 9, and then 4i times negative 4i, which is negative 16i squared. So the I squared here is really a negative 1, which will change this plus to a minus. And the I squared here also a negative 1, so it'll change this minus to a plus. So let's go ahead and look at this simplification. We have 9 minus 16, which is a negative 7, and negative 12i and negative 12i makes negative 24i, all over 9 plus 16, which is 25. Well, it doesn't look like anything will cancel or simplify here, but I do need to write it in a plus bi form, so I'm going to separate these out as negative 7/25 minus 24/25 I. And that'll be my final answer, this quotient, whenever I take 3 minus 4i and divide it by its complex conjugate 3 plus 4i. In this fourth and final example, let's go ahead and take a look at a division by complex numbers that includes some radicals as well. So we have the square root of 3 minus 2i, and that's a complex number, and we're dividing it by 5 minus the square root of 3i, another complex number. So again, we need to go about rationalizing the denominator, because not only do we have this square root of 3, we also have I, which is the square root of negative 1. So we're going to multiply both the numerator and the denominator by the denominator's complex conjugate. So 5 plus square root of 3i. 5 plus the square root of 3i. And again, so there's no confusion, I'm going to put parentheses around everything. And we'll see what this multiplication now looks like. In the numerator, it's just a series of distributions that I'm going to be really careful with. And in the denominator, it's just the firsts times the lasts. All right. So the square root of 3 times 5 is 5 radical 3. And the square root of 3 times the square root of 3i will be plus 3i. And negative 2i times 5 is minus 10i. And here we have minus 2i times radical 3i. So we'll have a negative 2 radical 3i squared. Okay, that's kind of wide there. So on the bottom here, these denominators, 5 times 5 is 25, and then negative radical 3i and positive radical 3i will be a negative 3i squared. Okay, so we'll come down here. These I squareds are actually negative 1s, so we'll change this negative to a positive. And this I squared, which is a negative 1, we'll change this negative to a positive. So now I have some like terms. This real part, 5 radical 3, and this real part, 2 radical 3, actually combines to make 7 radical 3. And then our imaginary numbers, 3i minus 10i, is negative 7i. And now that's all over 25 plus 3, which is 28. So I need to go ahead and divide this up because I need to write it in a plus bi form. So 7 radical 3 over 28 minus 7i over 28. And some nice things happen. This 7 and the 28 will reduce to a 1 and a 4. And this 7 and 28 will also reduce to a 1 and a 4. And so our final answer can actually be written as the square root of 3 over 4 minus 1/4 I when I write it in a plus bi form, and this I kind of trails along after the 1/4 to keep that b and the I part separate. So this will be the quotient whenever I take the square root of 3 minus 2i and divide it by the complex number 5 minus the square root of 3i.